Yo, so I kind of forgot about this YouTube channel for a little bit, so we're kind of just improvising this one. I'm gonna be honest, writing scripts is hard, and it wouldn't make this any higher quality. Let's be honest here. So imaginary numbers, right? Complex numbers, as the cool kids call them. What are they? Are they just random old things that mathematicians made up because they're batshit and crazy, or are they actually useful? The answer is kind of in between. I'm gonna be honest. They're a little weird. They're kind of like the magic of math. It's like you have like your normal numbers, and then you got the complex numbers, and everything gets a little bit wonky, just a little bit. It's not that bad. So I have no experience with this, so I'm gonna do my best. Have fun. All right, so there's three things really that you need to know to get the gist of complex numbers. So first, you need to know what the imaginary unit is. All right. So all it is math people were like, oh, the square root of a negative number. It doesn't have to be -1. It can be any negative number, but generally we just call it -1 because that's more broad or whatever. We represent this with the letter I, right? And we form things called complex numbers by combining it's called the real part plus some imaginary part. So it's I multiplied by some number. And we graph these on what's called the complex plane, right? So it's a little different from your regular coordinate plane that you know from algebra or whatever, right? So you got your real numbers on one axis, and then you got your imaginary numbers on the other, right? And you kind of graph numbers like that or something. So our imaginary numbers just made up. The answer is actually no. Mathematicians kind of actually know what they're talking about on this one. Kind of crazy. So where do they come from? So there's this thing called the fundamental theorem of algebra, right? Very big, spooky title for something that's very simple, mostly. All this states is that if you have a polynomial of n degree, right? So that means the largest term in the polynomial has n solutions or n roots, right? And all that means that it intersects the x-axis n times, right? For example, right, you have a simple equation like x squared minus 1, right? Just a simple parabola. Intersects the x-axis twice, right? -1, +1, two solutions. But the contradiction here, the little spooky bit that made mathematicians kind of angry for a while was this equation right here. X squared plus 1, slightly different than the other example, but this time it's of degree 2, so we'd expect it to have two solutions, or intersect the x-axis twice, but it doesn't, right? It's always above it. So like, what's going on here, man? The answer is complex numbers or imaginary numbers, right? Has no roots here, no solutions in the real numbers, but if you were to graph this on the complex plane, like we were just talking about, it would have two solutions, right? Specifically for this one, the roots are just positive and negative I, right? So yeah, complex numbers, not made up. Fun fact, the term imaginary number was meant to kind of make fun of mathematicians who took all of this seriously. Originally, it took a few hundred years before people kind of started to realize that there's some cool stuff going on here. But at first, they kind of just, said, "You gross, don't mess with that." Yeah. Some other important facts about complex numbers. Number one, every real number can be represented as a complex number, right? So five, the number five, is technically a complex number, right? It just has its a little imaginary part equal to zero, right? Zero I, so we just kind of leave it off. Going off from that point, get a little bit technical here. The cardinality of the real numbers is the same as the cardinality of the complex numbers. What does that mean in not gibberish? It means that there's the same number of complex numbers as there are real numbers. So you can't create more complex numbers than there are real numbers. Which is, I guess, maybe not too obvious, but is cool nonetheless, or maybe important to know. Thirdly, more gibberish, the complex numbers, or maybe more specifically the complex plane, forms A, a field, B, a vector space, and C, a metric space. What does all that mean? This is a really fancy way of saying they behave like normal numbers, right? So everything that you can do with complex numbers, you can do with real numbers, and vice versa. They just behave kind of how you would expect them to behave, right? So algebra is mostly the same, etc., right? The only real difference is like graphing complex functions, for example, which is a little bit different, but not too hard to grasp, right? I guess I didn't go over that, but it doesn't matter. They're the same thing as real numbers, more or less. I mean, they're different fields of study, obviously. There's real analysis, the study of real numbers, and then there's complex analysis, which is a whole nother thing. Yeah. Alright, so finally, why should you care about complex numbers? Really, you shouldn't. They're not too useful. I mean, there's a reason why they're called imaginary, or they used to be called imaginary numbers. So outside of like fringe parts of math, I guess complex analysis isn't that fringe. The only real application they have in the real world, the only real reasons you should care are like some parts of physics. I barely passed like classical mechanics in college, so don't ask me what this means. I just pulled that shit off Wikipedia, but quantum mechanics, relativity, that sort of thing. Apparently there's something called imaginary time. So like, good job physicists. You guys are doing great. Appreciate it. That's all I got. Have fun.